Oh, again, let's try to solve last question of this here. Let's see what it will be. Medium. Okay. One year in advance, there was a year which you will travel are given. 1,65 tickets are sold. 3 different ways. I have 3 different costs. That many days of consecutive travel. For example, if we get 7 days pass on day 2, we can travel for 7 days. So it's, yes, minimum number of dollars you need to travel every day in the given list of the days. So it's like previous question. What if? I don't think I will be able to solve this question. Just now I think I have to learn something about the topics. So it's dynamic programming. Let's see what is 150 problem. So there's remove duplicates from sorted arrays. Array 2 we solved like just remove duplicates from array 2 from sorted array. Now it's a little bit more complicated. Okay, non-decreasing order, remove some duplicates in place such that each unique element appears at most twice. The relative order of the element should be kept the same, since it's possible to change the length of the array. In some languages you must instead have the results be placed in the first part of the array norms. More formally, if there's key elements, return k after. So it's basically the same. One difference is at most twice. So in the first iteration it was just once, so we have to remove all duplicates. Here we have remove all but one duplicate. And yeah, so we will return 1 1 2 2 3 and empty place. And here we are returning just pairs of elements. Looks okay, yes. So basically it's the same problem. If we have 2 cursors, one which tracking place to insert element and another is to place what element to place in this. At the first point. So the second cursor should be smart, not first one. First one will be just counting the place to insert. So the second one should be smart. So let's start. So int left equals 0, int right equals 0. Probably boolean. Equals false, I suppose. Int. Yes, we are starting from first index because index at 0 will be always always correct. So we are starting from first element actually, because first element will be second position probably, and we should check. So we don't need this boolean, and while r is less than nums length, we will do as follows. We will check if there is like so we don't want to replace first. So we are starting from 0 anyways. We are doing like int ref equals nums 0. Doing int count equals 0. So if ref equals nums r, we are moving r forward, incrementing count, else if count equals equal or greater than 2, we have to insert oops, equals ref plus plus. We can do like that, and like that. Else we can do like that. So if it is more than 2, we will do additional insert, and also ref will be equals to nums r, right? And then we will return L. Like that. So when let's try. So we are starting from this anchor source here. Ref is 1 and count is 0. So we are going here. We are checking if it is correct. Yes, we're incrementing r to here and count to 1. Again, it's the same. We are incrementing r to here, count to 2. Then we are moving here, and it is this branch, count is equals to 2, so we are setting 1 to here, and then 1 to here, and moving cursor to here, left cursor to here. We're setting previous to 2. Then we are going to same loop, and we're checking if r is equals to previous, and it's true. So we're moving r to here, and count to 1, and then we are moving to we also have to set count to 1 and here count to 1. So yes. What's wrong? Yes, because there is incorrect comparison. So run again. Six out of bounds. Yeah, because we have to check bound first. And run again. It's suboptimal because we are doing like it's just not, we're doing this comparison each cycle. It's not very good, but yeah, I don't want to make complex logic. Why you are out of bounds? You shouldn't be. Let's check again. So 1 count is 1, previous is where it is here. 1 r is less than bound, so we are checking if previous is equals to none, and it's correct, we are implementing r. Left is in place count will be 2. Next here. Next here we're checking the same. Count is 2. R is 3. Next. Here is the same as previous. Yes. R here count is 2. Here the same, count is 3. R is here. Next. No, we are here. We are going here. We are incrementing R and count to 2. We are going here again. We are incrementing R, count to 3. We are going here. It's not the same, so we're checking count to 3, which is greater than 2. We are setting 1, 0 index to 1. Then we are setting second index to 1 and we're going to this index. We are checking if R is still in bound, so we're setting previous to 2 and we're setting count to 1. We're going to the next cycle. R is still here, so we're checking R is equals to 2. So we're incrementing count to 2 and moving R here. We are going here, R is still equals to 2, so we're incrementing count to 3. No. We're going, so we're going here. We're checking if it's previous. Oh, yes, we're going here. Count is 2. And we're in the next cycle. We are checking if it's equals to previous. We're going here. Main count to 3. It's a count. Answer, yes, that's correct. Because greater equals 2. Yes. So at least this is correct answer. Let's try to submit it. Let's see. Yes, it's a good solution in terms of performance, at least. We have something about relatively decent memory. Yeah, we are at the top of the curve. So yeah, I think that's all. See you tomorrow in New Year. So happy New Year.